Hello everyone, how are you? Hope you're having a good day. This video is about the second rule of algebra. We saw the first rule in the last video, that was do the same thing to both sides, and there was also a video on the zeroth rule, letters are numbers. The second rule of algebra is that BODMAS is reversed, kind of. So this video assumes again you have studied a little bit of algebra and also fractions, and in this case of course BODMAS or PEMDAS if you know it that way. Also, remember when we talk about multiplication and division, they are really the same kind of operation. A divided by B can be written by A times 1 over B, and although this is a different way of writing it, it's still relating the numbers in the same way. The same goes for addition and subtraction. A plus B is the same as A plus minus B. So the first rule told us how to move things in an equation, but we will still make lots of mistakes without the second rule. To see how BODMAS is reversed, we must remember that multiplication must be done to everything on each side of the equation. What do we mean by everything? Well, let's look at an example. Here are two equations. I used the same equations from the last video because it's not important what the numbers are. What's important is the form of the equation. On the right-hand equation, we've added brackets, and this changes the form of the equation. But these rules will work for any equation with the same form. So actually we can do BODMAS here, but it might be easier if we do SAMDOB. Let's start with the equation on the left. 3x plus 6 equals 18. We're going to do this equation both ways, and we'll start with BODMAS.
First, we divide both sides by 3 to get x on its own. This gives us a single x, but we must divide two other numbers by 3 to do this. 6 over 3 is 2, and 18 over 3 is 6, giving us x plus 2 equals 6.
Finally, we'll subtract 2 from both sides. X equals 6 minus 2, and I'm sure you can see what x is from there. Let's move on to doing it by SAMDOB. First, we will subtract 6 from both sides, and that gives us 3x equals 12. And then we divide both sides by 3, and that takes us immediately to the answer x equals 4. So both ways get us to the same answer, but one gets there in fewer steps. Now let's do the second equation. 3 open brackets x plus 6 close brackets equals 18. Sometimes people will say this as 3x plus 6 equals 18, but that can be a little confusing. Again, we're going to do it both ways, starting with BODMAS. Let's expand the brackets, and that will give us 3x plus 18 equals 18. And then we can divide both sides by 3, and that's fairly simple. We can just have x plus 6 equals 6. Finally, we can subtract 6 from both sides so that x is 6 minus 6, and that gives us x equals 0. Moving on to SAMDOB, first we will divide both sides by 3, and that means we can take the 3 off the front of the brackets, and that is equal to 18 divided by 3. So x plus 6 equals 18 divided by 3. Then we subtract 6 from both sides, which means that x equals 6 minus 6, and again we get to x equals 0. You can see that these equations were very simple, but the same rules will work with every equation. You just need to practice and you will get used to having equations that might have a fraction that cannot be simplified in them or something like that. So, rearranging equations is often easier when we use SAMDOB, but it can work both ways. Why is SAMDOB easier? Well, for that, we're going to talk about the way we refer to equations and parts of equations as terms. How many terms does this equation have? If you don't know what a term is, feel free to take a guess and you will see in a moment if your guess is correct. What about this one? How many terms does this equation have? And one more, this one. How many terms do you think this equation has? Well, in fact, I'll tell you that the first equation has 3 terms. There they are. The second equation has 4 terms. And the third equation has 4 terms. And if this seems strange to you, then just have a look at what's left and why do you think we are dividing our terms that way? We are dividing our terms that way because each term is separated by a top level addition or subtraction, or the equal sign. What do I mean by top level? Well, you can see that these plus and minus signs separate groups of other things which are all higher than them on the BODMAS hierarchy. The brackets, the orders, the division and multiplication, all of this is higher up than addition and subtraction. So these are the top level addition and subtractions. Of course, you can have other plus and minus symbols inside other terms, inside a bracket, for example, but those do not count for making new terms in the equation. The second equation is written as 4 terms, and you can see we have a plus, a minus, and an equal sign dividing up those terms. But really, it should only be 3. Plus 2 minus 3, that simplifies. So our next form is 3x minus 1. But there are numbers on both sides, so really we can rearrange, and after we rearrange this equation, there are only 2 terms. And this is how we simplify equations. Let's finish with one last example. Here we have quite a complex looking equation, but if you look carefully you will see that there are x's and y's and numbers on both sides of the equation. We can try and do BODMAS and divide these all over a common denominator to get to our answer, but it won't be fun. Let's rearrange the terms. So after rearranging by using our rule, do the same thing to both sides, then we are left with 8x minus 3x equals 7y plus 3y plus 13 plus 37. And if we simplify one more step, that gives us 5x equals 10y plus 50. That is a much simpler equation, but we can divide through by 5 as well, giving us x equals 2y plus 10. We have simplified the equation. So SOMDAB is easier because we get all the same terms together and then we simplify them before we start multiplying and dividing. It isn't always this easy. For example, you might have a reason to do something using BODMAS on one side of the equation and then SOMDAB to both sides. Then there are sequences which you can see deliberately breaking a simple answer into many terms, sometimes an infinite number of terms. But all of that is for another time. I hope that these 3 videos together have given you a better idea of how to work with algebra equations, but you still have a lot more to learn about algebra itself. Let me know in the comments which other subjects in algebra or any part of maths are confusing for you. Thank you for watching.